In this video, we're going to look at an A-star level question on differentiation from first principles. So before we move on to part 2 of the question, let's first have a look at proving this identity. So what we know about subtracting fractions is we can use that cross multiplication method. So let's do that. We can say 1 multiplied by x squared. Because there's a minus sign in between, we can say take away that second cross multiplication, which is x plus h squared all multiplied by 1. So I'm just going to write this out as x plus h all squared. All over the multiplication of the denominators, which is x squared multiplied by x plus h all squared. And then let's now focus on expanding and simplifying the numerator here, because the denominator is already matched that to the answer. So with the numerator here, x plus h squared is, well, when you square a bracket, you're just multiplying it by itself essentially. So we're doing x squared minus this here. Now x times x is x squared, x times h is xh, h times x is also xh, so they add up to 2xh because they're common terms. H times h is h squared, but because we're subtracting all of this, we're essentially doing x squared take away x squared minus 2xh take away h squared. X squared take away x squared cancels out, and we're left with minus 2xh minus h squared. So that's your numerator, and the denominator is just the one that was already there. So x squared multiplied by x plus h all squared. That's your answer to part I of the question. Let's now move on to part 2 of the question. So it's told you that f of x is x to the power of minus 2, and it's asked you to use differentiation from first principles to find f dash of x. So this is what it means by differentiation of first principles, and this is given to you in an exam. What you start by doing is the function that you're differentiating, we call that f of x, which is already done for us. So that's good. But I'm going to write this out as 1 over x squared. You'll see why later. In order to put into this expression here, we first also need f of x plus h, which is what you get when you replace x with x plus h. So this is x plus h all to the power of minus 2, which can be rewritten as 1 over x plus h all squared. Putting all of this into this expression here, we can say that the limit as h tends to 0 of f of x plus h, which is 1 over x plus h squared, take away f of x, which is 1 over x squared, all divided by h. So let's put a big bracket around this, all divided by h. And then let's simplify this as much as you can. Well, what you can sort of realize is this is similar to what we had in part I of the question. And that's the reason it was part I of the question, is because we can replace the numerator with all of this. So let's do that. We can say it's equal to the limit as h tends to 0 of minus 2hx minus h squared all over x squared multiplied by x plus h all squared. Great. And now we have to also remember to divide all of that by h, which is the same as multiplying. Actually, that's the same as multiplying h onto the denominator. I think that's the easiest way to do it. And actually, after you do that, what you can realize is that h is actually in each individual term, so we can cancel out h from each individual term. So we end up at the limit as h tends to 0 of minus 2x minus h all over x squared multiplied by x plus h all squared. Okay, where do we go from here? Well, let's think about it. When h tends to 0, what happens to this whole expression? Well, this here will tend to 0. So we can say that this tends to, well, the numerator will tend to minus 2x. The denominator, this h becomes 0, so this becomes x plus 0 all squared, which is also x squared. And x squared times x squared is x to the power of 4. Cancelling out a power of x, we get that this is minus 2x to the power of minus 3, which is correct because, well, x to the minus 2 just differentiates to minus 2x to the minus 3. And yeah, we've shown it that is true now by differentiating from first principles. Hopefully that will make sense, and if you have any questions with it, please let me know in the comments. Otherwise, thanks for watching. Be sure to like the video and subscribe.